Hi, my name is Tyra. I'm an international student at Trent University here in Peterborough, Ontario, pursuing a PhD in the Material Sciences program. Today I want to take you through a little bit about my journey through academia and what I do currently as a part of my thesis research. So let's go. My project has a direct global impact, specifically in the agricultural field, which makes it valuable to many worldwide. The UN projects that the world population may increase by about 500 million by the year 2030. This is only 6 years from now. For agriculture, this means that the demand on agricultural produce will also increase consequently. So it is very imperative that agricultural productivity is maintained to keep up with this demand. I'm working towards developing cost-effective and easy-to-use tools for efficient monitoring and detection of parameters related to agricultural productivity. I take advantage of the growing science and technology, specifically with the application of electrochemistry, to easily provide answers to agriculturally related questions. With the current advancements in science and technology, the tools developed here can also be adapted for use outside of agriculture, included in biomedical field. My research is exciting to me because I get the opportunity to contribute to the solutions of issues faced globally, like addressing the need for easy monitoring of agricultural productivity. There are lots of environmental contaminants that can be detrimental to the health of plants, and the chronic exposure of these contaminants like pesticides that may unintentionally harm crops, heavy metals from soil or the atmosphere, hydrocarbons, microplastics, and so much more will indefinitely be harmful to agriculture and to us in the long run. And this is why my research is so important. The technology that I develop can be used directly by the user, whether that be a farmer or analyst, to inform agricultural practices. I focus on the analytical measurement of important internal and external factors related to plants that can be an indicator of environmental contamination or crop health. For example, plants rely heavily on sugars for the regulation of growth and development. Therefore, any fluctuation to the sugar levels observed in plants can suggest changes to the health of the plant. The main and most abundant sugars in plants are sucrose, glucose, and fructose. So these compounds are of particular interest for monitoring plant-related measurements. Many handheld devices have been developed for monitoring environmental contamination and sugar content in plants. And devices that are designed to be small, compact, and portable are very important for considering the use by the consumer. With all of this in mind, my solution to addressing these issues relies on the development of smart sensors. Smart agriculture technology is rampantly becoming very popular in farming. You will be familiar with some tools like robots for soil analysis or harvesting, and drones for monitoring pests and weeds, soil management, vegetation mapping, etc. And overall, all these technology can help farmers with increasing their agricultural output and reducing adverse environmental impacts. Smart sensing technology can also have even smaller devices such as tattoo-like sensors that can be directly applied to a crop or sensors that can be directly inserted into the stem of a plant. While they can be made to be very aesthetic and cute, they offer very valuable benefits for on-site testing related to the ease of use, accessibility, cost, and offer the possibility for remote and continuous monitoring of an environmental contaminant and sugar content. This is where I plan to go with my research. Using electrochemistry and a little bit of creativity, we can design and fabricate small sensors in the form of disposable paper sensors, implantable sensors, or plant wearables that can be used in the field to help better inform personnel about agricultural productivity. Fundamentally, with the focus on bioanalytical chemistry and monitoring plant chemistry, this research can also help us to learn a little bit more about how plants may behave under various conditions. Thinking about my path to me pursuing my PhD, 3 things stick out to me as pillars of inspiration for me getting here. 1, support from people who are proud of my village. My family and close friends especially have selflessly been encouraging me on this journey. And they believe in me more than I believe in myself. And it's that encouragement that drives me to push through all the obstacles and is very high on the list of the reasons to why I am in this current position. And I also have my professors to thank. I have gotten a lot of encouraging words from several of them, not only at the university level, but this has been from primary school where teachers really looked out for students and really pushed for the success of students. and I'm happy that I got the benefit of that. The second one is my passion for science. I have always liked the idea of being in science and in the science field in some capacity, and I see it as a different way of making a valuable impact to the community, kind of from behind the scenes. And lastly, a curious mind. Research allows me to explore unknowns that help satisfy my endless curiosity about different things. I also thoroughly enjoy seeing things unfold. I love learning, and I get to do that every day while I do research. Having the opportunity to see ideas come to fruition and almost seeing light bulbs go off when an idea comes to mind, or the excitement of getting an experiment to work after several trials and errors brings a lot of joy to me, and I think that satisfaction is what keeps me going. I've always known that I wanted to be in STEM, but without those three factors always being at the forefront of my mind, I would not have made it as far as I have. Growing up, I was not exposed to or learned about many significant Black and/or female figures in chemistry or in science in general. And during my years in early education, many of the legendary change makers in science that I learned about from textbooks and classes were all white males. Though I have always had an interest in doing science, I lacked inspiration from well-known, successful scientists who look like me. However, this did not deter my eventual curiosity in becoming a scientist and overcoming the challenges associated with entering the field as a Black woman. Keeping all of this in mind, I personally still think that science still needs more work in terms of representation that could then foster the support of equity and inclusion. I think that mainly representation and diversity in groups are part of decision-making processes is integral in making lasting and impactful changes in the science communities. I truly believe that representation matters and would really like to see more diversity within academia. Boards and organizations who have the higher power or authority should always be representative of the people that they serve. Otherwise, we aren't really making the best impact that we think we are. To me, supporting equity and inclusion ultimately means that you are helping to enhance the voices of those who may not be able to speak up easily simply because of who they are. I think that there is so much more that we can do to support equity and inclusion in science, and any small change can make a really big difference. I believe that if we continue taking progressive action towards more inclusive initiatives and making an effort to being open to equitable solutions like sharing the stage with other underrepresented persons who also have valuable contributions, we would be moving in the right direction.